All right, let's try another one then. Questions, anything before we try another one? Anybody, anything? Okay, let's try another one. I think I'm gonna get you started on this one and then I might put you into breakout rooms, we'll see. But let's try this one here. For example, where's my next example? For example, x double prime plus 9x equals this function, sine of t, if t is less than 2 pi, and 0 if t is greater than or equal to 2 pi. And again, we're going to go with initial conditions of 0. So x naught is 0 and x naught prime is 0. Make life a little bit easier for you here. X double prime plus 9x equals this right-hand side piecewise function, sine of t if t is less than 2 pi, and 0 if t is greater than or equal to 2 pi. So once again, let's do the transform of the right-hand side first, and then we'll deal with the differential equation. So I can't use this one. I'm gonna skip a couple of steps here. Tell me if I need to slow down. We're gonna do g of t minus sine of t. My zero's in the wrong spot, so I gotta do g of t minus sine of t. This is gonna be 0 if t is less than 2 pi, and negative sine of t if t is greater than or equal to 2 pi. So that's what I'm looking at. Okay. A is going to be 2 pi, and so what we need is f of t minus 2 pi to be negative sine of t. I need f of t minus 2 pi to be negative sine of t. That means that f of t is negative sine of t plus 2 pi. Again, it's backwards. It's always backwards with a plus and a minus. So f of t is negative sine of t plus 2 pi. But this is cool. Sine is periodic. So basically what I've done is shifted this sine function by 2 pi. If I shift a sine function by 2 pi, I superimpose it on itself, right? It doesn't look like it moved at all. It doesn't look like it changed. So this can just be negative sine of t because you have a period of 2 pi. You've shifted the function by 2 pi, but with a sine or a cosine, that doesn't change the function at all. So I can just have negative sine of t. That's really cool. We like that. All right, front of your book, figure out the transform for that one, please. Go ahead and figure out that transform. What are we gonna have? So we've got an e to the negative 2 pi s, and then times 1 over s squared plus 1. That's the transform of your sine, right? E to the negative 2 pi s times 1 over s squared plus 1. That's not what I wanted. That's not what I was looking for. So what I really just found was capital G of s minus 1 over s squared plus 1. That's what I really just found because I subtracted that t. Capital G of s minus 1 over s squared plus 1. Grant, question.
When you're taking the transform of f of t, since it's negative, does that negative go with?
Yep, sorry, so my negative should go up in the numerator right there. Thank you. Yes, missed my negative. Thank you. All right, and so therefore, capital G of s, if I move stuff over to the other side, I'm gonna put this all together right now. Can we please do a 1 minus e to the negative 2 pi s over s squared plus 1? Are we okay with where that's coming from? 1 minus e to the negative 2 pi s over s squared plus 1. I'm finding a common denominator. Both of those pieces have an s squared plus 1 in them. So 1 minus e to the negative 2 pi s over s squared plus 1. Okay, that was the right-hand side. Let's do the differential equation now. So here's what we had. We had x double prime plus 9x equals g of t. X naught was 0, and x naught prime was 0. I'm going to skip writing the minus zeros. You got it? We're good. So we've got s squared capital X of s plus 9 capital X of s equals the thing we found on the right-hand side. 1 minus e to the negative 2 pi s over s squared plus 1. S squared, capital X of s, plus 9 capital X of s equals 1 minus e to the negative 2 pi s over s squared plus 1. So I can divide, I can split up here, and I am going to have capital X of s is 1 minus e to the negative 2 pi s over s squared plus 1 times s squared plus 9. 1 minus e to the negative 2 pi s over s squared plus 1 times s squared plus 9. All right, stop sharing my screen for just a sec. Doing good? Everybody's good up to this point? We're good? Yes? Good? All right, awesome. Let me give you partial fractions, and then I'm going to put you into breakout rooms to finish this problem. So let me give you the partial fractions decomposition. Here's your hint. We will put it up over here. It ends up that 1 over s squared plus 1 times s squared plus 9 is equal to 1/8 over s squared plus 1 plus negative 1/8 over s squared plus 9. If you were setting up partial fractions, you would need A, B, C, and D. It turns out that the s coefficients are both equal to 0. So 1 over s squared plus 1 times s squared plus 9 is 1/8 over s squared plus 1 plus negative 1/8 over s squared plus 9. Partial fractions decomposition. You can write it out if you want to. All right, I am now going to put you into breakout rooms and let you finish this problem. So we're going to do 4 rooms here. All right. Rooms should be open. You should get an invite. This is totally random, so we will see who ends up in what room. I did it randomly. Go ahead and join and finish up the problem.